Following the momentous inaugural strains of Zarya, Unity arrives not as a fleeting flourish but as a foundational keystone. Think of it like this: Zarya was the first step, bold and strong, like the first stroke of a painting. But Unity is different. It's like the glue that holds everything together. Picture it as a key piece that brings all the different parts of the International Space Station into one cohesive unit. Instead of just linking things together, Unity blends them seamlessly, making the ISS truly unified. Its 6 docking ports aren't just for show. They are like welcoming arms, inviting modules from all over the world to join together in the pursuit of science. Unity isn't just a connector, it's a symbol of how nations can come together to explore space. So while Zarya started things off, Unity is the foundation that ensures cooperation and collaboration will define the future of space exploration. It's a big step forward in history, marking a new era where countries work together to uncover the mysteries of the universe. Hi everyone, welcome to my channel. Today in this video, we'll see about the second module which began the ISS's journey into an International Collaborative Space Station, the Unity module or Node 1. Let's start the video. The Unity module. The Unity module, also known as Node 1, is the second pressurized habitable module after Zarya of the International Space Station. Launched to space, it provides crew members of the ISS with living and working spaces. It serves as the heart of the International Space Station. It acts as the vital link between the Russian and US segments, enabling the station's initial construction and subsequent expansion. Its 6 docking ports facilitated the attachment of numerous modules and spacecrafts over the years. The module contains over 50,000 mechanical items, 216 lines to carry fluids and gases across the station both ways, and 121 internal and external cables using 6 miles of wires to distribute power, enabling the continuous access to electricity around the ISS. Beyond simply connecting components, Unity houses essential equipment for astronauts' well-being. It provides storage for food and supplies, dedicated galley for meal times. Interestingly, it is often referred as the kitchen of the ISS by the astronauts. Unity doubles as the station's main food storage and even accommodates personalized treats sent from astronaut families. As the main connecting node, it also serves as a central gathering point for the crew, fostering a sense of community amidst the vastness of space. With its diverse functionalities and symbolic significances, the Unity module remains an essential part of the International Space Station's success. Its name, Unity, embodies a spirit of international cooperation that defined its conception and construction, symbolizing the collective aspirations of nations to explore beyond Earth's bounds. Unity served as a symbol of unity among diverse cultures and scientific communities. Manufacturer of Unity. The International Space Station's Unity module stands as a testament to collaborative spirit and technological prowess of nations united in space exploration. Spearheaded by the Boeing company, the primary contractor for the module's construction, the journey of Unity began in 1980s as part of the ambitious Space Station Freedom design. The main structure of the module took shape at Boeing's Missouri assembly facility in New Orleans, Louisiana, where meticulous attention was paid to its design, fabrication, and integration of subsystems. The module's genesis saw the convergence of efforts from various stakeholders, with NASA serving as the lead agency providing crucial funding, technical oversight, and engineering expertise throughout the development and operational phases. The Canadian Space Agency (CSA) played a pivotal role by contributing the Mobile Service System (MSS), known as Canadarm Robotic Arm, which proved instrumental in assembly of the ISS and attaching the Unity module to the Zarya module. Launch. Unity was launched on December 4, 1998 aboard the Space Shuttle Endeavour during STS-88 mission in Assembly Mission 2A, the second assembly mission. Docking with Zarya. The STS-88 mission, launched on December 4, 1998, is hailed as a pivotal moment in the history of space exploration, marking the initiation of the assembly of the International Space Station. This historic mission, executed by NASA astronauts aboard the Space Shuttle Endeavour, involved a series of meticulously orchestrated maneuvers, including the intricate docking of the Unity module with the Zarya module, conducted with precision amidst the backdrop of the weightless expanse of space. Now we delve into the details of this groundbreaking event, tracing the sequence of events that led to the successful docking of Unity with Zarya. The first crucial step in the assembly process occurred on December 5, 1998, as astronaut Nancy Curie skillfully maneuvered the shuttle's robotic arm, known as the Canadarm, to attach to the pressurized mating adapter PMA-2. PMA-2, serving as a pivotal docking component, was securely grasped by the Canadarm, setting a stage for subsequent maneuvers. With PMA-2 attached to Unity firmly in its grasp, the next critical phase unfolded as PMA-2 was meticulously aligned and connected to the ODS docking port on December 6, 1998. The precision of the Canadarm, coupled with advanced guidance systems, facilitated the seamless integration of PMA-2 with the ODS, culminating in the establishment of a vital link in the NASA ISS. This milestone indicated the attainment of the initial T configuration, with Unity and PMA-1 poised vertically above the space shuttle, laying the groundwork for the arrival of Zarya. On December 7, 1998, the spotlight shifted to the rendezvous and docking of the Zarya module, a pivotal moment symbolizing international collaboration in space exploration. Utilizing the Canadarm, astronaut Nancy Curie deftly captured and guided Zarya towards the PMA-1 docking port, a feat requiring precise maneuvering and coordination. As Zarya and PMA-1 aligned, the gentle nudging provided by the shuttle's thrusters facilitated the final docking, cementing the fusion of Russian and American modules in the vast expanse of space. With Zarya securely docked, the stage was set for pivotal moment of releasing Unity from the Canadarm's grasp and connecting it adjacent to Zarya on December 8, 1998. This maneuver necessitated a meticulously orchestrated extravehicular activity (EVA) conducted by astronauts Jerry Ross and James Newman, who diligently worked to establish vital connections between the modules, including power, data, and structural cables. This final step in the docking process marked the culmination of weeks of preparation and represented a significant leap forward in the construction of the ISS. As the assembly phase neared completion, the time came for the shuttle Endeavour to bid farewell to the NASA space station. On December 15, 1998, after 11 days of intensive work in Earth's orbit, the shuttle undocked from the ISS, marking the conclusion of a historic mission. As Endeavour slowly drifted away from the station, its crew gazed upon the marvel they had helped construct, a testament to the collective efforts of nations and the limitless potential of human exploration. Elements of the Unity module. Large cylindrical body. The Unity module, also known as Node 1, is a key component of the International Space Station. It serves as a hub connecting various modules and providing vital functions such as life support, electrical power distribution, and communication interfaces. The exterior of the Unity module is predominantly made of aluminium. Aluminium is a common material used in aerospace applications due to its lightweight properties, corrosion resistance, and strength to weight ratio. Berthing ports. The Unity module of the International Space Station ISS houses 6 common berthing mechanisms. These CBMs are essentially docking ports that allow other module spacecrafts or cargo vehicles to connect to the ISS. They're crucial for the assembly, resupply, and maintenance of the International Space Station. Now let's see a brief explanation of each of the 6 CBMs. Forward CBM, FCBM. This is located at the forward end of the Unity module and is used for docking with visiting space shuttle or other spacecrafts using the PMA-2. Aft CBM, ACBM. Positioned at the aft end of the Unity module, this CBM has PMA-1 attached to it, which is docked with the Zarya module. Zenith CBM, ZCBM. Located at the zenith upper side of the Unity module, this port is used for docking cargo spacecraft such as SpaceX Dragon or Northrop Grumman Cygnus. Nadir CBM, NCBM. Situated on the nadir lower side of the Unity module, this CBM also used for docking cargo spacecraft and other ISS components. Starboard CBM, SCBM. Positioned on the starboard right side of the Unity module, this port is primarily used for attaching modules during the assembly of the ISS. Port CBM, PCBM. Similar to the starboard CBM, the port CBM is located at the port side left side of the Unity module and is used for attaching modules during assembly. Now let's see the function and what modules are docked to the CBMs. On December 7, 1998, the Nadir had no modules attached. Same goes to the Zenith port and port and starboard. The forward facing port had the PMA-2 and PMA-1, PMA-1 being permanently attached to the aft side of the Unity. October 11, 2000. The Nadir port had PMA-3 attached, which is a new module, and the Zenith had Z1 truss segment, a new module of the truss segment, and the port side has no modules attached. The forward port had PMA-2, the aft side PMA-1. July 8, 2001. On July 8, 2001, the Nadir port had Zenith Z1 truss segment, port side PMA-3 relocated from Nadir berthing port to the port side of the boat, and starboard side none, and forward Destiny US Lab, which is a new module, and the PMA-2 attached to the forward side was relocated to Destiny's forward port, and the aft port had PMA-1 attached. On July 12, 2001, the Nadir port had PMA-3, Zenith Z1 truss segment, port PMA-3, and starboard had Quest Airlock, a new module, and the forward port had Destiny, and aft end had PMA-1. On October 23, 2007, the Nadir port had PMA-3, which was relocated from the port berthing port to Nadir for the attachment of Node 2, Harmony. Zenith had Z1 truss segment, and the port side had Harmony Node 2, a new module, and starboard had Quest Airlock, forward Destiny, and aft end had PMA-1. Later that day, the Nadir had PMA-3, Zenith had Z1 truss segment, and the port had none. Harmony was relocated to forward berthing port of Destiny. and the starboard had Quest airlock, and forward had Destiny, and aft end had PMA-1. On February 8, 2010, the Nadir had no modules attached. PMA-3 was relocated to forward berthing port of Harmony for its later attachment to Tranquility module, and after Tranquility was installed to port side berthing port of Unity. Then PMA-3 moved to the port side berthing port of Tranquility. The Zenith side had the Z1 truss segment, port had Tranquility Node 3 and Cupola, which are the new modules. Starboard had Quest airlock, forward had Destiny, and aft end had the PMA-1. And the final modification to the Unity was made on February 24, 2011, when the Nadir had PMM, Permanent Multipurpose Module, Leonardo, which is a new module. Zenith had the Z1 truss segment, port had Tranquility and Cupola, starboard side had Quest airlock, forward side had Destiny, and aft end had PMA-1. Mating adapters. Imagine you have two different types of electrical sockets. One is a traditional 3-prong socket and the other is a 2-prong socket. In order to connect a device with a 3-prong plug to a 2-prong socket, you need an adapter that converts the plug to fit the socket. Similarly, on the International Space Station's Unity module, there are different types of docking ports called PMA, pressurized mating adapters. PMA-1 and PMA-2 are two such adapters that was launched with the Unity module of the International Space Station in mission STS-88. They serve as intermediary connectors between different types of spacecraft docking systems. As Unity acts as connecting node between ROS and USOS, it needs an adapter that connects the APAS androgynous peripheral attachment system docking port to the berthing port that the Unity and other USOS segments are made with. Storage lockers and racks. The Unity module, or the kitchen according to some astronauts, serves as a central area for crew meetings and especially food storage, preparation and consumption by the crew. Within this space, storage lockers and racks play a vital role in organizing and securing various food items and supplies necessary for meal preparation and dining in the microgravity environment. Dimensional specification. The Unity module, a pivotal component of the International Space Station, boasts dimensional essentials for its role as a vital hub within the operating laboratory. With a mass of 26,225 pounds and measuring 18 feet in length with a diameter of 14 feet, Unity provides crucial passageways between different segments of the station, facilitating crew movement and equipment transfer. In conclusion, the Unity module of the International Space Station ISS stands as a testament to humanity's unwavering commitment to exploration, collaboration, and scientific advancements beyond the confines of our planets. Since its historic docking during the STS-88 mission in December 1998, Unity has served as the cornerstone of the ISS, facilitating international cooperation, collaboration, and scientific advancements beyond the confines of our planet. Since its historic docking during the STS-88 mission on December 1998, Unity has served as the cornerstone of the ISS, facilitating international cooperation among spacefaring nations and enabling groundbreaking research across a multitude of disciplines. I hope this video on Unity module of the ISS was interesting. I'll meet you in the next video with another ISS module. Take care. Bye.